Today in this video we are going to learn how to display temperature and humidity on TM1637 4-digit 7-segment LED display. The components required for this project are TM1637, that is 4-digit 7-segment LED display, and Dht11 Arduino Nano board. Then jumper wire, we have male to male jumper wire and male to female jumper wire and breadboard. So basically TM1637 4-digit 7-segment display are found in many common household appliances like microwave to display temperature, time, etc. A typical display has 4 7-segment light emitting diode or LEDs. Each of the segment A through G contains a separate LED which can be controlled individually. Each of the input pins to connect to a specific LED segment by inputting an 8-digit binary number to the corresponding pins of the 7-segment display. A particular number can be formed by activation specific LEDs. For example, for 0, the input will be 1 1 1 1 1 1 1 0, and for 5 input will be 1 0 1 1 0 0 1 1. TM16 4-digit display has 4 pinouts, that is as we can see, clock, data input output, VCC and ground. Clock DIO, that we have to connect these pins to any digital pin of Arduino Nano. Now we are left with the 2 pins. One is ground, and that we will connect to the ground, and another is VCC pin that we will connect to the VIN or 5 volt of Arduino Nano board. Next we have Dht11, that is digital humidity and temperature sensor. Humidity is the measure of the water vapor present in the air. The level of humidity in air affects various physical, chemical and biological processes. Dht11 is a digital temperature and humidity sensor. Dht11 is a low-cost digital sensor for sensing temperature and humidity. This sensor can be easily interfaced with any microcontroller such as Arduino, Raspberry Pi, etc. to measure humidity and temperature instantaneously. To measure the surrounding air, this sensor uses a thermistor and a capacitive humidity sensor. Dht11 sensor consists of a capacitive humidity sensing element and a thermistor humidity level. The IC measure process this change resistance value and change them into digital form. For measuring temperature, this sensor uses a negative temperature coefficient thermistor, which causes a decrease in resistance value with increase in temperature. Dht11 has 3 pin, that is the +1 indicates the VCC pin, -1 indicates the ground pin, and the out indicates the data pin. Next we need breadboard and jumpers wire as are required to make the connection between component and Arduino board. Arduino Nano is used to burn and run the program. Now we will make the connections. Now we will place your Arduino Nano in middle of the breadboard, so we have more number of pinouts to make connections. Make sure your nano board is inserted well. Now the clock pin, we will connect the clock pin to D3 and DIO pin to D4. Okay, we will make a common ground and a common VIN on breadboard. So we will have space for connecting Dht11 sensors, VCC and ground, as we don't have large number of pinouts on Arduino Nano board. Next we will place the Dht11 sensor over here. So as I said, the positive pin indicates the VCC. We'll connect the VCC. Here the white, here the negative, we will take the positive one as VCC and the negative one as ground. So positive is VCC and negative is ground. Now we will connect the positive of Dht11 to positive and negative of Dht11 to negative. Next we will connect the data output pin to D2. So we will get data from D2. Now the connection is complete. We will just have to make our code. So I will share the screen with you. First we will install Dht11 library and TM1637 library from managed library option, and write code to display humidity and temperature that will display on TM1637 4-digit 7-segment display. We will first define our clock and data pin, data input output DIO pin number. In void setup, we will set the pins and set the display to 0, that is off. In void loop, we will write our project function that will run in loop. So DHT read 11 DHT underscore pin will call the Dht11 data pin and its value. Int temp is equals to DHT temperature. We will store the integer value of Dht11, that is temperature, in temp variable. Int humidity is equals to Dht humidity. We will store the value of humidity in humidity variable. Next we will apply formula to convert the received value of temperature and humidity and store them in variable and call them afterwards. We can do one thing also. For we will in setup we will write serial.begin at 9600 baud rate, so we can verify if we are getting the value or not. Sometime our TM1637 is not working, so we will get to know about that from there. Okay. We will to get the value of DHT, we will write serial.println temp in the void loop also. Next, int digitone t is equals to temp divided by 10, that is what will be our temperature will get divided by 10, and that value will be stored in digitone t. Okay, next we will create a variable int digit 2t is equals to temp percentile 10. Okay, next we will call TM1637 dot display to display the value of temperature on our TM1637 4-digit 7-segment display. Okay, so so we have this like 0 1 2 3. So we will write 0 for placing our value at the first place, 0 comma digit 1 t, that will show the digit 1 at the first place, that is 0. Next we will write TM1637 dot display 1 digit 2 t. So this will place the value of second digit 2 on the second place, that is 1. Okay, next we will write call TM1637 dot display in brackets 2 into digit 1 h. So what it will do, it will place the value of humidity, first value of humidity, on third place, that is 2, and same for the last place. we will write TM1637.display 3 digit to H, and we will give a delay of 3 or 5 seconds as whatever will be suitable for you. So if the value changes, it will change on the display also. So this delay, I am giving 3 seconds delay, so delay is 300 milliseconds, and our code ends here. Now we will just burn the code in Arduino Nano and get our values. So as you can see, we have 15 degrees Celsius at present and 61% humidity in the atmosphere. We can see the value here, and we can also see this value on serial monitor. So as you can see, as the value after 3 seconds changed, it changed on the screen on serial monitor as well as on our digital display. So here ends our code and project. Four-digit 7-segment display are among the commonest display component in several of our household appliances like digital radio, clock, refrigerator, air conditioner, and many others. They are used to display information in form of number and some letters. This data can be sensor reading like a cooker and a cooler, or time in digital clock. We can use this project as our personal weather display device. This project is presented by ABL Education. At ABL Education, we think innovatively and bring our innovations to reality. There are many projects at ABL Education YouTube channel. You can watch and make DIY web project for yourself at home. For any query, leave comment below or contact us at the link provided in the description. Do subscribe ABL Education to learn and make new projects. Thank you. Have a nice day.